Hey everybody, my name is Jimmy Fusil. I'm an M&E technologist with Tsecond, the makers of the BRYCK platform. My background, just so you know, because I'm going to spend some time talking about the film industry a little bit, is been working in post-production and filmmaking for the last 25 years, and been really, oh, thank you. And I want to talk about how the BRYCK platform, this particular platform, has been used in that industry to facilitate new ways of working, new ways of producing films, and also especially advanced imaging techniques, which are very, very expensive on the performance side, on the data density side, and really talk about, kind of how this is being used today, right, by some of our customers. So as I said, I need to start with a little bit of history because sometimes it's easy to forget that it's only in the last 25 years that filmmaking and TV making became a digital endeavor, a file-based endeavor. It was a photochemical and mechanical process for 100 years before that. And what's been incredible to me in the last 25 years is to see the explosion and the importance of data in that industry. Just like any other industry, but this filmmaking industry, this TV making industry, is, I think, a good example of what we've seen in all these other areas. First, we started by making film on actual film and on cassette tapes and such. And there were few digital processes, but there were some files, but not many files. And then very quickly, we went into this digital transition where files became the core assets. All of a sudden, like Mana was talking about earlier, the files became the most expensive things. They represented millions of dollars of investment, and they became the thing that need to be protected and shuttled from place to place. And then new digital techniques emerged. VFX techniques, virtual production, all these techniques that are very data-centric. And that meant that there were more types of assets, more types of digital assets, more file types to deal with. And then those files became bigger because they had to be more precise. We went from SD to HD to 2K to 4K to 8K. And every time we're doubling, quadrupling the size of the data, right? And finally, especially since the pandemic, we've seen these workflows be distributed. So now the data needs to be in multiple places, and so it gets replicated. So instead of having one copy or two copies, you have 16 copies because the data needs to be here, it needs to be there, it needs to be in the cloud, it needs to be at the edge. And the thing to remember is that production is like the most edge-centric activity that I can think of. A bunch of people showing up with computers. Some of those computers look like cameras. Some of them look like recorders. Some of them look like computers. And they all show up on the set, and they build this system to make a movie every day or to capture data every day. So that, to me, is probably what you all deal with every day as well. But here, everybody brings their own little piece of gear, their own little, and then they build a network together to make sure that they talk to each other, but not too much because everybody has their own role, right? But at the end of the day, they generate a tremendous amount of data, as well as ancillary data, that basically encapsulates all the value of the work that's been put into that day. And most productions cost anywhere from $50,000 to maybe even $500,000 a day to produce, right? People who have built sets, actors who are very expensive, all this preparation and equipment investment that goes into it. So this is very, very high value data. And this is where BRYCK really becomes a very good value proposition, because BRYCK is all about protecting that data and moving that data around and making sure everybody has access to it. The other part of making a movie is post-production, and that happens also at the edge. It's not a glamorous set. It's not some far-off location. It's a dark room somewhere in a metropolis somewhere, but still all the machinery to make a film is at somebody's knees, or it's in a closet. If you're lucky, it's in a little data center that has actually some cooling. That's awesome. But a lot of the time, these are what I would call like extreme edge conditions or non-data center conditions. Then you have the VFX companies who have their own data centers and where things are very well maintained. But still, people are working in this self-contained manner. And for reasons of both content security and performance, the data needs to be really close to the people who use it. It needs to be really close to the workstations that access it.
So can I just clarify something?
Yeah.
From what you guys have said so far, my understanding is that BRYCK is a high capacity, high throughput storage device, and that's it.
And it's highly portable.
And portable, right?
Yes.
But that's it. It's a storage device.
It is a storage device, yes.
Okay.
We will talk later about the processing piece of it, which is what we're really touting today and releasing today with you all, is this BRYCK AI capability and how that allows not only processing, not only storage, but also processing at the edge. But it's the high throughput, I have to underline, is key to processing, right? I can have the best processors, but if I can't access my data, which is usually where the bottleneck is in filmmaking or in TV, then my workstation is useless. If I don't have access to all the data that I need to have access to, my workstation. So why is media production done at the edge? Just to summarize, processes are very latency sensitive. Directors don't want to wait to see something. They need to see it immediately. They need to see the interaction between somebody turning a knob and something happening needs to be immediate. They're not tolerant of compression because they need to look at things at the maximum resolution, maximum fidelity. And the techniques require a lot of processing. A lot of this is image making. And image making means GPUs, and it means files that, maybe this partially answers your question. One file might be 500 megabytes, right? And there's 24 of them every second. And so I need to access those files immediately, and I need to be able to play them back in real time, which could be 24 of those files a second, 60 of those files a second. And then the data volumes, because of that, become very large. The average production produces, and I mean really average, like your average network TV show produces 5 terabytes in 8 hours of shooting, right? And that's a very average one. Your multi-camera setup, or if you're filming an event that has 16 cameras, just multiply that, because that production that I talked about is maybe using a camera or maybe 2, right? So multiply that by 8, multiply it by 10. So they're very large data. And then that data needs to be turned around right away, made available to the next phase of production, whether that's editing or review or whatever. And a big part of the problem still in production is that getting data to the cloud remains, especially that volume of data every day, remains a challenge. That's because you're often dealing with the last mile problems that I'm dealing with at home, right? This is the only bandwidth available to me at this location is what the hotel gives me. There is no hotel where I am because I'm shooting on the mountaintop. There is, or even if I have really good connectivity, I need to move 5 terabytes at the end of the day, and I can't go home until I do that. And you know what? It's 9 o'clock, and I have to be back at 5 a.m. So those remain challenges. I'm not saying the cloud doesn't get used in production. It does. Its elasticity is very useful for VFX. It's very useful for places where you can plan and say, I'm going to put things up there and process them up there and take them back down, or I'm going to use it for distribution of part of my files. But when you're dealing with a whole mass of files, you need something that can move terabytes or hundreds of terabytes within days, right?
So how is that going to work? Because in the end, your storage device may be really fast throughput, but you still got the links to the cloud, and you're limited by that.
Yeah, so a lot of the times we're talking about edge transfers, right? The other capability that this offers is taking this to a place where there is actually connectivity. So going from a set where I get 50 megabits or 100 megabits and taking it to some data center downtown where they actually maybe have a privileged link up to AWS or Google, and where I can move up to 100 gigs a second, right? That's great. I just need to be able to move it from that set, that location, and get it to that place. And honestly, that connectivity is too expensive for anyone who has a post-production facility or film facility to establish. Nobody can really afford to have that 100 gigabit connection that Equinix has. You can maybe get gigabit. You can maybe get 10 gig. And then you're really splurging. You're a big company at that point in this domain.
To what extent is this plug and play from location or studio to post or to editing? I'm thinking of the connectivity, the ports, and because you're moving, what you described on location or in the studio is a network environment, and then you're moving it into a more standard, office environment.
So usually on set you're dealing with kind of a 5G Wi-Fi plus, radio frequency environment. So there's a lot of congestion, and it's kind of an improvised, often, environment. And really, people are not relying on that network to carry that core data. They're relying on that network to make things to talk to each other, carry metadata, or carry a proxy from, there's two outputs from the camera, the core footage, and then a little thinned out version of the image that somebody needs to see on the tablet or something like that. It's the film industry is not special in that it uses the same connectivity that everybody has. It uses 100 gig. It uses fiber channels still quite a bit. And you're just using what everybody else would be using in any IT environment to make do. So there's nothing unique about the protocols that are used. There's something unique about the demands, and we'll talk about this on some of our use cases, that a single stream, what's required of a single stream of data, right? Instead of your problem being that you have 100 office workers trying to hit this data at once, you just have one really expensive worker who needs 2.5 gigabytes a second. And he's dealing with somebody right next to him who needs the same access, also at 2.5 gigabytes a second. And that becomes the challenge. I don't know if I'm answering your question now.
Yeah, I'm just thinking that there's portability in the BRYCK.
Yeah.
It's super helpful.
Yeah.
As you go through production from,
location
capture from location and studio back into the production studio and so forth. And I'm imagining, a typical PA grabbing a bunch of bricks and throwing them in the car and driving off to
exactly.
Right? Yeah. But then there's the technical issue of the connectivity for data collection on location.
Yeah.
Versus the connectivity for data supply. I mean, I have questions about read-write speeds and that sort of thing.
Yeah.
But there's also just is how is a tech plugging in here and there's some kind of access point used in the studio versus plugging in over there where the SAN connection. I mean,
Sure. So on the set, for example, this would be my workstation.
On set, right?
On set, this is my workstation. I have a laptop. And I'm attaching to the BRYCK, and I'm getting cards from the camera that have a USB 3 or USB-C, or a Thunderbolt 3 connector. And I'm basically using this workstation to move things from SSD to other SSD, right? It's very improvised.
At the end of the day, there's a line of creatives. So.
There's a line. This is not some of the more sophisticated productions, very high-end productions, they'll have a network engineer there who will have a nice switch that everybody plugs into or something like that. But most of the time, I have this thing on a cart and I'm wheeling it around, chasing behind the camera, making sure I collect the data.
Why can't you plug it directly into the camera?
So we can, and I will get to that.
Okay, great.
So, and then on the other side, you're dealing with people who have switches and all the traditional infrastructure that you would need to access data quickly. It's a little bit more improvised quite often on set.
As long as I brought it up, is read-write speed roughly
Yeah.
equivalent
Yeah.
for the BRYCK in general?
So yeah, it's completely
It's both. It's read and write
it's equivalent.
optimized. Yeah.
It's equivalent, right? And so I think that I'll talk a little bit more about a use case, and you'll hear about that. Here, I'm not going to go through this. This is just how data has to flow through a production. It comes out of capture, it goes somewhere. This is the place where everybody decides the data is, but then it has to get distributed to all these places who end up exchanging data amongst themselves anyways. So this is just to highlight the fact that data has to be highly mobile in production. And I need to highlight the customer challenges that are not necessarily technical challenges, but those are really the important ones. The technology here is at the core of solving creative issues and logistical issues, not technology issues. Issues like deadlines. You printed the posters. This is when the movie comes out, right? That's when the trailer said it would be. You have a lot of locations that you need to serve. You have balanced costs because you have a budget. And we don't want to spend budget on connectivity. You want to spend budget on things that are in front of the lens. And finally, it's an image processing process. And that is very expensive from a processing standpoint. So I'm going to talk about 3 use cases that I think will illustrate the performance and the advantage and how people are using the BRYCK. This first one is a fairly simple one. There was a miniseries that was being finished in New York, and now the director and the cinematographer are in Los Angeles. They are not available to go back to New York. There's 130 terabytes of data that needs to be accessed. And these are, people at this post-production company called Picture Shop need to make it happen because they need to finish color grading, which is the last phase of post-production where you're tuning the look of the film or TV show and making everybody look great and conveying the atmosphere. They need to do that with somebody who we call above the line, so somebody who gets a front credit in the movie and and gets paid very usually well, and whose time is very precious. So there's all sorts of tricks that they can deploy to do this. Sometimes remotely logging into a color correction workstation from LA to New York to do the grade, and then beaming back the video in real time and allowing them to see the effects of that. But this is a very tactile process where people are moving knobs and working almost in an automatic manner. And so what they need is really fast response. And so the delay that they were experiencing by doing this kind of remote control workflow was not working. So what they did instead was copy the 130 terabytes in a few hours, get on a plane with the BRYCK, bring it to the facility in Los Angeles, plug the BRYCK right into the color correction workstation, which needed 1.5 gigabytes of throughput, which is well within the capabilities of the BRYCK, and be able to work and access those 130 terabytes worth of files immediately without pause, and basically be able to have access to every single frame that was shot, have access to all the different versions of the cuts without having to move data, reconstitute the file system, the file tree, so that that workstation could access those files. To answer your question about throughput, it depends on the configuration of the server, but basically you have your BRYCK, you have your tray that you plug the BRYCK into. The tray gets connected to what we call a storage server, which is, we have specs for it. We're not religious about what type of server it is. But then you go out, whatever protocol you want to use, 100 gig or fiber channel. And then we deliver per server, 10 gigabytes a second. So the connectivity between the tray and that server is up to 40 gigabytes a second. The connectivity out of that server to a workstation is 10 gigabytes a second to any client, right? And a lot of what we see our customers do is connect via SMB or NFS over RDMA, so they can take full advantage of that, not across 100 links, but really across like 20, 10, 5, or 3 links. So this is our first kind of use case. Our next use case, a little bit more complex and a little bit and pretty high profile and very cool, which was working with Sphere, who were making their first film for the Sphere, which was called Postcard from Earth. And their requirements were really, really high because they had filmed at 16K, so 16,000 pixels by 16,000 pixels at 60 frames per second. Obviously, you couldn't play that back in real time. So they made small files that were 4,000 pixels by 4,000 pixels, uncompressed at 60 frames per second. That required 2.5 gigabytes a second for regular playback at speed so that the director could see actually what they had filmed and color corrected. Really interesting architecture there because they wanted to be very self-contained. So the simplicity of deploying the brick, which basically to them shows up kind of like a NAS, and they can just connect directly to it via NFS over RDMA, which allowed them to do copies of files from their other storage or to their other storage at up to 5 gigabytes a second, and they were able to maximize to 9 gigabytes a second of reads. That really helped them when they were having multiple streams at the end of the film where they had to render all those 16K files. They needed to have that fast access. They needed to saturate what the brick could do at that point. We offered to, go into a 2-server configuration, which would have given them up to 20 gigabytes a second access to the brick, but they were already so happy that basically they could work at 10 gigabytes a second that they didn't go for it. The other cool part of this was, again, we talk about data transport, but it's not about, this is not a shuttle drive where you pick it up and then you go to the next place and then you copy the files off of it. You can do that for sure, but the best thing for them was that they could just pick up the brick in Burbank, which is where they were doing post-production, fly to Las Vegas, plug that brick right into another tray, and access the data right away. There was no copy process that would have taken an hour or 2 hours, which already would have been fast. They could just get right to work. So now we're going to talk about really highest debit from cameras, and I think I'm going to address your question. So we have this integration with RED cameras. RED cameras are cinema cameras that are used by major filmmakers all over the world. They are capable of capturing 8K at 120 frames per second. And so they really push the limit of how many pixels get captured and recorded at any time. We worked with them because they saw a need emerging for recording, instead of recording to the little cards that usually, onboard cards that they record to record multiple cameras to a centralized place. The reason for that is you don't want to spend a whole lot of time managing media, managing data at the end of a shoot, especially when you're filming a concert that has 24 cameras running at any given time, or when you're filming a volumetric video that has 50 cameras running at any given time. The output of these cameras basically was off of a 10 gig fiber connection that went into a switch. Each camera for 8K at 120 frames per second was outputting 800 megabytes a second. So with the BRYCK single server architecture, we could do up to 12 of those cameras to a single brick. With another server, we could do up to 24. And basically record directly to the brick through that protocol. And then we put it to use, and we thought, okay, who's going to want to do this first? And it was probably the craziest project I was ever a part of, which was an art project that wanted to shoot in the middle of the Atacama Desert, which is basically where they train people, or they simulate Mars. It's in Chile. In the middle of summer, they're going to have 3 robots controlled by AI do a performance and record the performance with cameras mounted on them, RED cameras mounted on them. And they wanted to record 20 hours a day, and they didn't want to take breaks to change cards. And it was going to be in the middle of the desert, and it was going to be in a month. And we're like, okay, we think we can do this. extreme operating conditions of heat, dust. Doesn't get much more edge than this, you guys. I don't think so. This was the server room, so to speak. You know, a dusty little shack. But basically, what we were able to prove is not only like the performance of day in, day out for a week, recording 20 hours a day, gathering over 150 terabytes of footage from these cameras, recording at high resolution, but also the workflow of recording and then immediately being able to process while you're still recording, being able to make other copies for insurance reasons, for security reasons, and do all of that in this really harsh edge environment. You know, we talked a little bit about our upcoming BRYCK Mini. This is the kind of workflow where BRYCK Mini is even more valuable, right? Where you don't have to deal with a server, you don't have to deal with a tray. You have this one single inbuilt thing. But this really, you know, kind of tested the limits of what we could do, not only from a performance standpoint, but really from a reliability and security standpoint, or data security, data. So from that, the workflows that we are now exploring are ones of, again, recording from multiple cameras, recording to the BRYCK, processing immediately in place at the edge, having access at the edge from the BRYCK, and then lifting the BRYCK out of the tray, taking it somewhere else to be processed again.